So if we look at problem number 16 on page 28, it states that we need to use the graph at right to find the following information. First and foremost, it wants to know over what intervals is my graph increasing. So where does my graph start to go up and where does it stop going up? I think the first thing for me to do is to find the point where it's going to start increasing. And it looks like -5 would be where that's going to start. And then I'm going to take from -5 and trace and see that the x value -5 will then have me increasing all the way up until where x is equal to -2. So I have from -5 to -2, my function is increasing. Now, there's another point where my graph is in fact increasing, and that point is at +2, and it looks like it's increasing all the way to +5. So again, if we look at where it's increasing, the other interval would be from +2 to +5. So x is increasing in between those two numbers. Now, I also need to find the values for which x is decreasing, and so oddly enough, that's going to be the opposite of when it's increasing. And so the starting value of my function is at -7, and it looks like my x values or my y values are decreasing all the way to -5. And then when I take a look at where x stopped increasing, which was at -2, the y value was at +8 and started to decrease again. It looks like it goes down all the way to where x is equal to 2. So from the x values of -2 to +2, my y values are decreasing for my function. Now next up, I'm asked to find the domain. So I want to know all of the values of x, all of the inputs that have outputs as defined by the function in question. So if we look at our graph, the x values that our function touches ranges all the way from the starting point of -7 to the end point of +5. And the dots that mark those endpoints, the vertices that we see there, are closed. So since they're closed, both -7 and +5 are included in our domain. So I'm going to use a bracket because -7 is included in the domain. And I'm going to use a +5 and a bracket around that because it is also included in our domain while we discuss that in interval notation. Next up, looking at the range again is the set of all of my outputs. It's the set of all of the possible outputs, all of the possible y values that my graph has. So I need to look at the very bottom of my graph, and I need to look at the very top of my graph. I want to find those minimums and maximums that we're about to talk about here in a moment. So if I go to the absolute minimum of my graph, that absolute minimum is at x equals -1. And again, that ordered pair was closed. The vertice on that point was a closed vertice, which means that I would have a bracket. And then the absolute maximum, or the highest possible output that we see across our entire function, is at +8. And again, that was a closed vertice, which means that that point would also be included and have a bracket around it. So again, we just found our absolute minimum and maximum. And so if you look at your range, you can see that the absolute minimum is going to be the point where our y value is -1. But since we need to provide it as an ordered pair, I see that the ordered pair would be -5, -1. Again, I want the coordinate point. And my absolute maximum, if I go back to that coordinate point, I see that it is where x is -2 and y is +8. And that gives me my absolute minimum and my absolute maximum. Again, those were the 2 points that correspond with the low and high end of my range. Now, when we've discussed relative minimums and relative maximums, that just means the different highest and lowest points that we have had. And so if I want to provide the relative low points and the relative maximums that we have, I'm not talking about where my end points are for the graph, but where my minimums and maximums are in between the two. And that includes all of them, including my absolute minimums or my absolute maximums. So I know already that one of my minimums is -5, -1, because that's what's already been discussed. But then my graph is increasing, and then it's decreasing again, and it has a turning point at the point 2, 2. And so 2, 2 is where my graph goes from decreasing to increasing, which would mean that it does in fact constitute a relative minimum. And then when we take a look at the maximums, other than the two endpoints, which again, we can't say if those are minimums or maximums because the functions are only defined between those 2 points, but I would say that the relative maximum is the only maximum I was given, which is -2, +8. So now we've identified the key features of our graphs, and we're ready to move on to the next.